Hello and welcome to the Fusion 360 Essential Basic 3D Modeling course. This course is perfect for beginners in 3D modeling with Fusion 360. If you are new to 3D modeling or just starting out, you are in the right place. Our goal is to help you understand the basics of 3D modeling in Fusion 360 step by step. We will start with 2D sketching, a crucial foundation for creating 3D objects. You will learn about essential tools for creating 2D geometry, and we will discuss how to precisely define shapes with constraints and dimensions. Next, we will use these 2D sketches to create 3D solids. You will get to know the basic tools for creating 3D models in 3D CAD systems. This course is intentionally short, designed to quickly equip you with the fundamental knowledge you need to start creating simple 3D models on your own. Think of this course as the beginning of your adventure with 3D modeling. It's designed to give you a solid foundation for your continued learning journey. Let's dive in and start shaping your 3D modeling skills. In this lesson, we will start creating a 3D solid, and we will start by creating a sketch. 3D CAD systems often work in such a way that we create a 2D sketch based on which we create a 3D model using the operation of creating 3D solids. And step by step with this method, we will create a 3D model. In this lesson, we will start by creating a sketch, and to create a sketch, select Create Sketch, click the icon, or from the Create menu, select Create Sketch. These are the same options, so you can choose either from the icons or from the drop-down menu. Now, in the next step, you need to select the plane on which we will create this sketch, and we can choose between the XY plane, XZ plane, and YZ plane. And select XY plane, so it will be a top view plane. And to select a sketch plane, click on this plane with the left mouse button. And next, we will create a simple geometry, and we will create a rectangle. And as in the case of selecting the Create Sketch command, in this case also we can choose the command either from the icon or from the drop-down menu. We have three options for drawing a rectangle, and in this case, let's select 2-point rectangle and select two vertices of the rectangle lying on one diagonal, and select any 2 points in the working area to draw a rectangle. The command to draw a rectangle is still active, and we can create further rectangles, but in this case one is enough. And to cancel the rectangle drawing command as well as other commands, we can press the escape key on the keyboard or right click and select cancel. We have a rectangle, but this rectangle at this point has no specific dimensions, nor does it have a specific location. Location can be relative to other geometry or to the origin, and we use either dimensions or constraints to determine the location. And here what you see, these symbols next to the lines define constraints, and checking or unchecking the constraints turns the visibility of constraints on or off. These constraints determine whether a line is vertical or horizontal, and this means that there is some kind of limitation placed on these lines, and you cannot slope this line. These lines always be horizontal or vertical. Only removing the constraint will allow the line to slope. And to delete a constraint, select the constraint and press the delete key. The constraint has been removed, and this line is no longer locked as vertical line, and we can change its slope. And to do this, grab the corner of the rectangle with the left mouse button and move it slightly. And you can see another constraint has appeared, and this is a coincident constraint, and this constraint specifies that the endpoint of one line and the endpoint of other line are at the same point and are connected to each other. And if you delete this constraint, we can separate these points. Grab the left mouse button and move it slightly, and at this point these points are no longer connected to each other. And we cannot create a 3D model based on this sketch because this sketch is not closed, and to create 3D geometry from a 2D sketch, the sketch must be closed geometry. And let's return to the form of the geometry before we deleted the constraints, and let's manually add the constraints that we removed. To make this line a vertical line again, select this line and select the horizontal vertical constraint. This line is already a vertical line, and this constraint is still active. We could select next geometries that we would like to specify to be vertical or horizontal, or we can press the escape key to end this command. And when it comes to specifying constraints, we can first select the geometry and then select the constraint, or we can first select the constraint we want to apply and then we can select the geometry. Let's select coincident constraint and select two endpoints of two lines. And now these points are connected to each other. Press the escape key to cancel this command, and we are back to the geometry that was at the beginning. We will continue this example in the next lesson. Let's continue the example from the previous lesson, but we will leave the sketch for a moment. To do this, click the Finish Sketch button. And if you create projects, whether in Fusion 360 or any other program, it is worth saving projects at the beginning of work. And to save the project in Fusion 360, click the Show Data Panel icon and create a new project. Let's name this project, for example, CAD Training, and press Enter to confirm. Then double-click with the left mouse button on this project to go to this folder. And now this folder is active, but our file is not saved yet. And to save the project, expand the File menu and select Save. Then specify the name of this file, for example P1, and the location was automatically selected as CAD Training, but here you can change the location where the file will be saved by clicking on the arrow. A window will open in which you can select the folder where you will save this file. However, let's set location of CAD Training and click Save, and the P1 file has been saved and it is visible in the CAD Training project. And if you stop working on a file and want to open it later, just double click the left mouse button on selected file in the data panel and you can continue the working with this project. Let's close the data panel so that it doesn't limit the workspace. And now let's learn about navigation in Fusion 360, that is how to pan, rotate, zoom in and out. And first click on the username icon and select Preferences. Then as pan, zoom Orbit Shortcuts, select SolidWorks, and click OK. Navigation when sketching and when working with a 3D Solid works the same way. To zoom in and out, rotate the mouse wheel. If you press the mouse wheel, you can rotate the view. And if you press the Ctrl key and the mouse wheel at the same time, you can move the view in the work area. And if you press the Shift key and the mouse wheel at the same time, you can zoom in and out by moving the mouse. We can also use the navigation cube, and here you can select basic views, and you can also rotate these views. By right-clicking in the workspace, a pop-up menu appears, from which we can also select commands. To exit this menu, press Escape key, and let's go back to the sketch. Previously, we have finished the sketch, and now to return to editing the sketch, expand the tab with the sketches in this project. Then right-click on the sketch that we want to edit in the list of sketches and select Edit Sketch. We have moved on to editing the sketch, and we can continue working on this sketch. And at this point, this sketch has no specific dimensions and no specific location. If you left-click on the geometry, you can freely change the dimensions and positions of the geometry. And when creating 3D models in 3D CAD systems, we usually want the geometries to have precisely defined dimensions and locations. First, let's define the dimensions of this sketch, but now this geometry is selected, so left-click outside the geometry to deselect all geometries. And to add dimensions to a sketch, select the Sketch Dimension icon, or select Sketch Dimension command from Create menu, or simply press the D key on your keyboard. Then select one of the longer sides of the rectangle, the initial dimension of the selected geometry, and the information select additional sketch geometry or location for dimension will appear. This means that we can add dimension between two geometries, or as in this case, we can specify a dimension of one geometry and then simply specify the location of that dimension. That is, you need to click the left mouse button in the place where the dimension is to be placed. We don't have to do this precisely, we can move the position of the dimension at any time. And after specifying the dimension location, a window is activated in which we can enter the specific value of the dimensioned element. Enter here 100 and press Enter key. The dimensioning command is still active. Now select one of the short sides of the rectangle and define the length of this side as 50 millimeters. OK, and to finish dimensioning, press Escape key. And even though this rectangle is already dimensioned and the rectangle has no more dimensions, we only have 2 dimensions in the case of a rectangle, we can still move this rectangle freely in the work area. The position of this rectangle is not yet defined, and we can determine the position of the geometry relative to other geometry or relative to the origin of the coordinate system. We can specify this using dimensions or using constraints, and in this place, let's place the lower left corner of the rectangle at the origin of the coordinate system. To do this, with the Ctrl key pressed, select the lower left corner of the rectangle and the origin of the coordinate system, and select Coincident Constraint. At this point, the corner of the rectangle has been placed at the origin of the coordinate system, and notice that the sketch geometry has turned black and the black color of the geometry means that the sketch is fully defined, that we cannot freely change its dimensions and position. And when modeling in 3D CAD systems, we strive to ensure that the sketch is fully defined. This is not necessary to get a 3D model based on the sketch, but it is very helpful in the further stages of work because we will not accidentally change the shape and position of the geometry. And if you want to change something, we must do it consciously. For example, by editing dimensions, and press Escape key to cancel this command. And to edit a dimension, simply double-click the left mouse button on the dimension you want to edit and enter a new dimension value. Press Escape key to cancel this, and let's finish the sketch. Click the Finish Sketch button, and we will continue working with this project in the next lesson. Let's edit this sketch. Right-click on the sketch in the sketch list and select Edit Sketch. And let's create more geometries. We will draw 2 circles and 1 slot. And to draw a circle, we can use the Center Diameter Circle command, or we can use one of the options from Create Menu, Circle, and we can use one of these options. Select Center Diameter Circle, and to draw a circle, select the center point of the circle and another point to determine the diameter of the circle. Select these points by left-clicking in the work area where the geometry is to be placed. And when it comes to drawing geometry, at the beginning we draw the geometry initially without paying much attention to details. We don't have to focus too much on where we will place the center of this circle and what the diameter will be, because in a moment we will use constraints and dimension to determine the location and dimension of this circle. The circle drawing command is still active, and this is worth paying attention to in the initial stage of learning Fusion 360. After selecting a command, it is still active until you cancel it or select another command. Press the Escape key to cancel the circle drawing command, and now we will create another circle, but instead of drawing a circle, we will use the mirror operation. And however, for mirror, apart from the fact that we need geometry, the copy of which we will create, we also need a line that will be the axis of symmetry, the axis for mirror feature, and we will create such a line. Select Line command, and to draw a line, select 2 points of the line. As you can see, we can draw further segments of this line. However, in this case, we only need one line segment, one line. So press the Escape key to finish drawing the line. And this line will be a construction geometry, that is auxiliary geometry that will not take part in the operations of creating a 3D solid based on a 2D sketch, but will be auxiliary geometry in a 2D sketch, and we can define dimensions and constraints relative to such auxiliary geometry, or we can use such geometry as an axis for mirror feature. And to make this geometry just auxiliary geometry, select the geometry and select construction as line type. The line has been changed to a dashed line, and now this line is a construction line. And if the line is still selected, before you proceed to adding the mirror copy of the circle relative to this line, click somewhere outside the geometry to deselect all geometries so that no geometry is selected. And to add a mirror copy of the geometry, go to Create menu and select Mirror Feature. Then select Objects and Mirror Line, and to select objects, activate Object Selection by clicking the Select button, and by default it is active, highlighted in blue, and we can select the circle. If we had more geometries, we could select additional geometries, but now click Select button next to the mirror line and select the line as the axis about which the mirror copy will be made. And as you can see in the preview, we already have a second circle, which is a mirror copy of this circle relative to this line. Click OK to confirm it, and now we have two circles, and when you change the position of one circle, the position of the other circle also changes. Let's dimension one of the circles. Select the circle and select Sketch Dimension, and as the diameter of the circle, enter 10 millimeters. And notice that the diameter of the second circle has also been changed. Let's dimension the distance between the centers of the circles. The dimension command is still active. Select 2 points of the circle centers and enter 30 millimeters. When it comes to dimensioning geometry, we can dimension the geometry or the distances between points. Next, let's determine the distance from the center of the circle to the left side of the rectangle. Select the side of the rectangle and note that the dimension of the length of this line has been activated. But now when you click on the center of the circle, you can determine the distance of the center of the circle from this line. And here enter 15 millimeters. The circles are already dimensioned, but their location is not yet fully determined, and we will deal with this in a moment. The dimension command is still active, so click Escape to cancel this command. And now, on the other side of the rectangle, let's create a slot, and to create the slot, expand the Create menu, select Slot, and select Center to Center Slot. And to create a slot using this command, you need to specify the start center point, next specify the end center point, and next specify the point on slot. That is, we need to select 2 points of the slot to determine its length and the third point to determine the width of this slot. Press Escape key to cancel this command, and then with the Control key pressed, select 2 points and the construction line and select Symmetry Constraint. To place the slot symmetrically about the construction line, press Escape key to cancel the Symmetry Constraint command, and if you change the position of one point, the position of the other point will also change and the shape of the slot will also change, but the slot will be located symmetrically about the construction line. There are still a few things you should pay attention to. We can still move the slot freely, and the color of the slot is still blue. This means that the sketch and slot are not fully defined. Only the rectangle geometry is fully defined, that is fully dimensioned and fully constrained. A rectangle has specific dimensions and a position relative to the coordinate system, and in the case of a slot and circle geometry, we don't have that yet. Let's deal with the slot. With the Control key pressed, select 2 points of the slot, select the Sketch Dimension command and enter 30 millimeters. Then you need to specify the width of the slot and the distance of the slot from the edge of the rectangle, dimensioning is still active, so select 2 vertical slot lines and enter here 10 millimeters. And then select this line and enter here 15 millimeters. Press Escape to cancel the dimensioning command, and it looks like we have all the dimensions added, but the geometries are still blue. Here the geometry of the rectangle is only black, and black geometry means that the sketch is fully defined, that is, it is fully dimensioned and related, which means that we can no longer freely change this sketch. This makes it more difficult to accidentally damage the geometry, and as for the slot and the circle geometry, they are not fully defined. That is, we can change the position of these geometries, and you can check this by left clicking on the geometry and trying to slightly move the geometry. In this case, we can move the geometry up and down along the y-axis, and when it comes to dimensions, we can no longer freely change the dimensions. So the dimensions are already defined, and the location of the geometry is not fully defined. And in this case, the construction line that was supposed to pass through the center of the rectangle is not associated with the rectangle. The rest of geometries are constrained to this line, and the distances of the geometry from the edge of the rectangle are added, but this line has no specific position in the y-axis. So all geometries except the rectangle can be moved along the y-axis. Let's add a symmetry constraint here so that the construction line lies in the center of the rectangle. And when it comes to constraints, we can add constraints by first selecting the geometries for which we want to apply constraints and then selecting the constraint. Or we can select the constraint first and then select the geometries. Make sure that before you select the constraint, no geometry is selected. Left-click outside the geometries to ensure that all geometries are deselected. And let's select the symmetry constraint and select 2 long sides of the rectangle and then the construction line. The construction line lies in the center of the rectangle and all geometries are black. This means the sketch is fully defined. Press Escape to cancel the symmetry constraint command, and in this sketch we can no longer freely change the shape and position of the geometry. Any geometry change will need to be conscious, and we can do this by editing dimensions or constraints. This sketch is complete. Click Finish Sketch button, and based on this sketch we will create a 3D solid. In this lesson, we will create a 3D model based on this sketch. What is worth paying attention to is regular saving of work progress, and if the project is saved, to save work progress, just click the Save icon and then click OK. And the work progress has been saved, and now we will move on to creating a 3D model based on the 2D sketch. When it comes to creating 3D models, the method of using 2D sketches to create a 3D model is very often used. We can use sketches to get a solid based on the sketch, and to create a 3D model based on a 2D sketch, select Extrude Operation. You can click this icon, or from Create menu select Extrude. And after selecting the command, the selection profiles to be extruded is active. The field highlighted in blue means that the selection of feature with this field is active, and by pressing the mouse wheel you can slightly rotate the view to make it easier to select the geometry and select a profile based of which a 3D solid will be created. Select the area defined by a closed sketch, excluding holes, and then you need to define the distance, that is the length of the extrusion. In this case, it will be the height of the 3D solid that will be created based on this sketch. You can do this by dragging the arrow to appropriate value, or you can enter the value in this field or in the distance field. Set this value to 5 millimeters. This is the height of the 3D solid, and when selecting profiles we can select more than one profile. In this example, if you want to get a solid without holes, you would also need to select circles and slot geometries. Okay, let's deselect these geometries and click OK to confirm. And this solid was created from a 2D sketch, and Fusion 360 is a parametric system, and this gives a huge advantage in designing 3D parts. When creating 3D models, we work with parameters, and it may not be visible at first glance, but the dimensions of the sketch or the extrusion distance are parameters that we can edit during design, even if a 3D solid has already been created based on the sketch. This is very useful, especially in projects whose final shape may change. For example, we design a part of a device and physically make such a part, for example on a 3D printer or on a CNC milling machine. We install this part in the device, conduct tests, and it turns out that corrections need to be made, and modeling the part from scratch, even if it wasn't difficult, would be time consuming. Therefore, having the ability to edit model parameters to create a revised model or other dimensional variant can save a lot of time. If you need to change something in the sketch, you can edit the sketch, and sketches that were created during part design are located in the Sketches tab. And to edit a sketch, right-click on the sketch you want to edit and select Edit Sketch. And to edit a dimension, double-click the left mouse button on the dimension you want to edit and enter a new dimension value. Change the dimension from 100 to 120 millimeters. OK. And thanks to this, that the sketch was fully constrained and fully dimensioned, the geometries didn't break. And you must remember that if you edit a sketch that is not fully defined, the geometries may dislocate and the sketch may lose its shape. Click the Finish Sketch button, and the changes we make in the sketch are visible on the solid. Save your work progress by clicking Save icon and OK, and we will continue this project in the next lesson. Let's create the next stage of this 3D solid, and as before, we will create another 3D solid part based on the 2D sketch. And apart from that, we can create sketches on the basic work planes of the coordinate system, on the XY plane, XZ plane, or YZ plane. We can also create sketches on the faces of the solid. And to create a sketch on a model face, select the face, left-click on the face on which you want to create sketch, and then create sketch. Draw a circle approximately in the center of the solid, and cancel the circle drawing command by pressing the Escape key. And then let's place this circle symmetrically in the center of this solid. And to do this, we will create two construction lines. Select Line command and create two lines. And by the way, a little tip: if you are drawing lines and want to draw several separate lines, after drawing one line, you don't have to press the Escape key to end the line drawing command. You can left-click on the Create and Continue symbol that appears after you have created your first line segment, and clicking this symbol will stop drawing the current line, but will not completely cancel the line drawing command. This way you want to have to select the line command again to create another line. Okay, escape to cancel line drawing. And then with the Ctrl key, select these two lines and select construction as line type. In a moment we will place these lines so that they lie symmetrically relative to the sides of the rectangle, so that the horizontal line lies between the long sides of the rectangle and vertical line lies between the short sides of the rectangle. But as you can see, the construction line that should be vertical is not. In this example, I deliberately drew this line so that it is clearly visible that it's not vertical. Horizontal vertical constraint could position this line perfectly vertically, but using the symmetry constraint, the line will also be vertical. Simply put, if the construction line is to be placed symmetrically between the vertical sides of the rectangle, the symmetry constraint will also require this line to be vertical. Let's add symmetry constraints to the construction lines. Left click outside the geometries to ensure that all geometries are deselected. Select the symmetry constraint, then select the two short sides of the rectangle and construction line. And after the adding symmetry constraint, the construction line is perfectly vertical and displays exactly in the middle of the rectangle between the short sides. The symmetry constraint is still active. Select the long horizontal sides of the rectangle and the construction line between those sides and press escape to cancel the symmetry constraint. Now let's place the center of the circle at the center of the solid, and we will use construction lines for this. Select the coincident constraint, select center of the circle and select the vertical construction line. Then again select the center of the circle, select the horizontal construction line, and in this way the circle was placed in the center of the solid. We used construction lines that were related to the edges of the solid and related the center of the circle to these lines. This has the advantage that if the dimensions of the solid are changed, regardless of these dimensions, the circle will still lie in the center of the solid. And as you can see, even though the position of the circle is specified, the circle is still blue because it's not yet dimensioned. Select the sketch dimension, select the circle and enter 35 millimeters. OK, and press escape to finish dimensioning command. The sketch is black, which means the position and dimensions of the sketch are fully defined. Click Finish Sketch button to exit the sketch, and based on this sketch, let's create another segment of the solid. Select Extrude command. Select the circle sketch as a profile to extrude. Specify the distance to 25 millimeters and click OK to confirm. And in this way, based on the 2D sketch created on the model face, we added another stage of this 3D model. Let's save work progress and we will continue working with this file in the next lesson. Now let's create a hole in the center of this solid, and we will also create this hole based on the 2D sketch. We will create a sketch on the face, select the face and select Create Sketch. Then select to draw a circle, and we will create a circle such that the center of this circle lies in the middle of this face. Simply make sure that the center of the circle coincides with the center of the wall, which also has the shape of a circle. Please note that when you hover over the center of this face, a symbol will appear, and this symbol defines the center of the circle. If you click here, the center of the new circle will be placed in the center of this face. Then specify the location of the second point to create a circle. Press Escape to cancel drawing the circle, and the center of the circle is related to the center of the circular wall, and we get this constraint automatically, but we can do the same by adding the constraints manually. Delete this circle, select and press delete, and draw a circle anywhere, and escape to cancel drawing the circle, and then select the coincident constraint, select the center of the circle, and when you move the cursor near the center of the face, the center point of this face will be highlighted, and select this point. And in this way, the center of the circle was connected to the center of the face. In both cases, using automatic constraints and adding constraints manually, we get the same effect, and we can think about which way is better. Automatic constraints have the advantage that you don't have to perform additional steps, you don't have to select a specific command, and you limit the number of clicks. This will usually be a faster way. However, there may be a situation in which it is difficult to use automatic constraints, and the constraints added manually, even though additional steps will be required, will be much faster, and more importantly, they will make us sure that we have used the exact constraint that was necessary. When creating projects on your own, and as you gain experience, you will be able to assess in which situations it is better to add constraints manually and where to use automatic constraints. For me, one of the situations where I tend to use manual constraints is in projects where there are different geometry snaps close together. Then, to make sure I specify the constraints correctly, I first draw the geometry somewhere off the side and then add the constraints manually. Okay, select the sketch dimension and select the circle and enter 25 millimeters as the diameter. Okay, and click finish to exit the sketch. Now, based on this sketch, we will create an extruded cut of the sketch. That is, we will create a hole in the solid. When it comes to creating a hole based on a 2D sketch, we also do it using the extrude operation. Select the extrude operation and select the circle sketch as the profile to extrude. And to get a hole in a solid, you need to change the type of operation. Notice how this operation changes if you drag the arrow up. The operation type was changed to join, and another fragment of the 3D solid was created. And the next part of the solid would be connected to the previous stage of the solid. Now drag the arrow down, and the operation type has changed to cut. By adding an extrusion in this way, we created a material cut from the solid, and using this operation we can create holes and pockets in solids. In this case, we want to create a hole in the solid, so we will create it this way. But I would like this hole to be throughout the entire body. Therefore, we must specify the appropriate extrusion distance. We can do this using an arrow, or we can enter a specific value, and at this point we have a hole throughout the entire body. But this hole will be throughout the entire solid only until the height of the solid increases. Click OK to accept this operation with these settings. And as you know, when designing parts in Fusion 360, we can make changes to previously added operations. Let's assume that we need to change the extrusion of the length of the second segment of this solid, which was created by extruding the circle. And to edit this operation, locate this operation in the operation history. You can do this by clicking on each operation. Then the fragment of the solid that was created using this operation will be selected, or you can select this fragment of the solid and then the operation that was used to create this segment of the solid will be indicated in the operation history. And to edit an operation, right click on the operation icon and select Edit Feature, and now enter a new extrusion value. For distance, enter 35 millimeters. OK. And now pay attention to the hole. When you change the extrusion length, the hole is no longer throughout the entire solid. And by the way, let's use another useful feature, the cross-section analysis, which will allow you to analyze the 3D solid in places that are difficult to access and visible in the main view. From the Inspect menu, select Section Analysis, then select the face of the solid. This face will define the cutting plane. Then drag the arrow to -25 millimeters, or enter the value in the distance box, and in the preview you can clearly see how this function works. Click OK to confirm, and the model view in the workspace will be replaced with a cross-section view. And you can turn off the section visibility or you can remove it. And to turn off the visibility of the cross-section, expand the Analysis tab and click on the eye icon next to the cross section, and the full model view will then appear in the workspace. You can also delete the cross section. To do this, right click on the section in the Analysis tab and select Delete. And after deleting all cross sections, the Analysis tab will also disappear. And cross-section analysis can be very useful, but let's get back to the hole in this solid. And after changing the extrusion length of the cylindrical part, the hole is no longer throughout the entire solid. And if you want the hole to be through all the time, regardless of the height of the solid, we can do it very easily. Let's edit the operation by which the hole was made. And now, instead of entering a specific value for the cutout extrusion distance, select All as Extend Type. Click OK to confirm the changes. And selecting this option will cause the circle cutout to be extruded through the entire solid, which means that regardless of the height of the solid, the hole will always be through. If you want, you can change this by changing the extrusion length in the first operation or in the second operation. This option can be very useful in many cases and makes modeling much easier. If you want to make a through hole, we don't have to wonder how far the cutout should be, we just do it throughout the whole body. And just as we can create a 3D model based on a 2D sketch, that is, we can add material, we can also create a cut extrusion based on a 2D sketch in order to subtract material from a 3D solid. These are two basic ways of creating 3D solids based on 2D sketches in 3D CAD systems. In this lesson, you will learn what a circular pattern is and how it works. Let's create another project. In Fusion 360, we can have many projects open, and each project will be on separate tab. If you have a project open, to create another project, simply click New Design or select New Design from File menu. The new project has been created and we can start working with the new project without having to close other projects. However, if there is no need for other projects to be open, I suggest closing this project. To do this, simply click the X on the tab next to the name of the project you want to close. And let's start this project by creating a sketch of a 100 millimeters diameter circle on the XY plane. Select Create Sketch and select XY plane as the sketch plane. Then select Circle Drawing command and select the circle center at the origin, and then specify the circle diameter. And you can do this while drawing a circle. Instead of pointing to a point on the circumference of the circle to determine the circle's diameter, we can simply enter a specific diameter value when drawing the circle. Enter 100 millimeters as the circle diameter and press enter to confirm. Click Finish Sketch button to exit the sketch, and based on this sketch add an extrude of 10 millimeters. OK. And now let's create another sketch. Select the top face of the solid and select Create Sketch. Then let's draw a circle. Cancel the circle drawing command by pressing the Escape key, then select Horizontal Vertical Constraint and select the center of the circle and the origin of the coordinate system, and using this constraint cause the center of the circle and the origin of the coordinate system to lie in one vertical line. So in this case, in a line coinciding with the y-axis. Select the Sketch Dimension command and select the center of the circle and the origin of the coordinate system and enter 40 millimeters as the dimension value. And the dimension command is still active. Select the circle and enter 10 millimeters as the circle diameter. The sketch is fully defined. Click Finish Sketch to exit the sketch, and then based on the sketch let's create a hole. Select Extrude, select the circle sketch as Profiles and drag the arrow down to -10 millimeters and click OK. A hole has been created in the solid, and now based on this hole we will use the circular pattern tool to create additional copies of this hole. We will create 10 holes evenly spaced on the solid. From the Create menu select Pattern and Circular Pattern. Then as object type select Features, and this selection will allow you to select a feature, for example an extrude feature that created a hole, as an element to be copied in a circular pattern, and the object's selection box is active. Select the hole as the object to be copied in a circular pattern. You can select this feature or you can select the hole on a solid. Then click the Select button next to the axis to activate the selection of the axis around which the circular pattern will be made. And as the axis in relation to which the circular pattern of the hole will be created, select the Z-axis. Just click on this axis with the left mouse button. And as for the axis of the circular pattern, it can be one of the axes of the coordinate system, it can be an edge of a solid or even a sketch line. Then for the quantity enter 10 to specify the number of copies of the hole that will be created in the circular pattern, and click OK to confirm. And in this way we quickly and easily created holes in the solid. The use of patterns can significantly speed up and facilitate modeling, and another type of pattern is a rectangular pattern. We will discuss this later in this course, but now let's return for a moment to the other parameters of the circular pattern. Let's edit this operation. And the circular pattern has two more important parameters that are worth discussing at this stage. The first is distribution. At this point, the holes were evenly spaced along the circumference of the circle. This is because the full is selected as distribution. If this parameter changed to partial, the angle parameter is activated, and here we can enter the value of the angle at which the circular pattern will be arranged. Enter here, for example, 180 degrees, and the number of occurrences is still the same as before, only in this case the 10 holes are arranged at the angle of 180 degrees. That is half the circumference of the solid. Okay? Enter here 360 degrees. Okay, and another important parameter is suppression. Checking this parameter allows you to deselect copies so that these copies are not created in a circular pattern. Simply put, the circular pattern will be created without any deselected instances. Okay, let's go back to the initial settings, which have 10 evenly spaced holes. Click OK, and let's save this project as P2 and OK. In this lesson you will learn how to add fillets and chamfers. If you do not have this project open this project, and to add a fillet or chamfers to an edge there are few ways to do it, and you can first select the edges that you want to round or chamfer and then select the command, or you can first select the command and then select the edges. First, let's add fillet, and with the Ctrl key pressed, select the edges to be rounded. OK, and from the Modify menu, select Fillet command or select Fillet icon, and then specify the fillet radius, enter 2 mm, and the radius of this size is added to the selected edges. If you click OK, the selected edges will be rounded, but let's cancel this operation. And when it comes to adding roundings, we can also add roundings to all edges of the selected face. Select the top face of the solid and select fillet, and set the fillet radius to 2 mm, and this way all edges of the selected face will be rounded. Okay, let's cancel this operation, and now we will add chamfers to the edges of the solid, and adding chamfers and fillets works in the same way. And as I mentioned earlier, we can first select the edges and then select the command, or we can first select the command and then select the edges. In this case, select chamfer command from the Modify menu, and then select the edges to be chamfered, and set the chamfer size to 2 mm. And when adding chamfers or roundings in this way, we can select the edges by simply left-clicking on the selected edges without having to hold down the Ctrl key. In a similar way, we can add chamfers to all edges of the selected wall. Then instead of an edge, select a face and set the chamfer size. And as you can see, adding chamfers and fillets is very simple, and these are very useful operations. Chamfers and roundings often improve the functionality of the finished part made on the basis of a designed 3D model. Previously, we discussed the circular pattern, and I mentioned the second type of pattern, the rectangular pattern. This type of pattern is also worth getting to know at the initial stage of learning Fusion 360, and when it comes to a rectangular pattern, similarly to a circular pattern, we can easily get additional copies of the selected feature. but in this case arranged along a line and in a direction perpendicular to this line. It will be arrangement of features in the shape of a rectangle. First, let's create a new project and let's create a new sketch, create a rectangle, select sketch dimension 150 millimeters here and 80 millimeters here. Okay, and let's draw a circle. Select sketch dimension, select the center of the circle and this line and enter here 15 millimeters, and select the center of the circle and this line and here enter 10 millimeters, and select the circle and enter 10 millimeters as diameter. Click Finish Sketch to exit the sketch and select Extrude. Select this sketch as profiles and add 10 millimeters extrusion. OK. And now let's add more copies of the whole using a rectangular pattern. From the Create menu, select Pattern and Rectangular Pattern. Then for object type, select Faces and select the face of the whole. In this case, we cannot select features as the object type because the created hole is not a feature. It was created together with extruding the rectangle, and it is one feature with the entire solid. But in such cases, we can select the faces option, and this will also allow us to get copies of the holes. The next step is to select the axis, activate the select box for the axis parameter, and select the long edge of the solid. Then drag one arrow along the long side of the solid and another arrow along the short side of the solid. Then you need to define the parameters of the rectangular pattern for axis 1 and axis 2. We can enter these parameters in the appropriate fields, or we can do it by dragging the arrows. First, let's focus on axis 1 and the quantity and distance parameters. Quantity parameter should be clear. Here we specify the number of copies in the selected direction, and for axis 1, enter 7 as quantity. And as for the distance parameter, it is the distance between the first and the last occurrences of the copied feature. In this case, it will be, for example, the distance between the center of the first hole and the center of the last hole. The center of the first hole is offset from the left edge of the solid by 15 millimeters, and if you want the center of the last hole to be offset from the right edge of the solid also by 15 millimeters, enter 120 millimeters as distance in axis 1. This is because we subtract 15 millimeters on one side and 15 millimeters on other side from the total length of the solid. And as for axis 2, it works similarly. For quantity, enter 4, and for distance, enter 60. Because the center of the first hole is moved from the lower edge of the solid by 10 millimeters, and we also define this distance between the center of the last hole and the upper edge. In a rectangular pattern, there is also an option to turn off selected copies, and to do this, select suppression parameter and select the copies that are not to be excluded in the pattern. Okay, let's create the pattern with all instances. Okay. And this created a rectangular pattern in two directions, but if necessary we can add pattern only in one direction. Then we need to drag only one arrow and define the parameters for one axis. And in this quite simple and quick way we added additional holes, and if we were to do something like this manually without using the rectangular pattern operation, it would take much longer. A rectangular pattern like a circular pattern can make the part modeling process much easier and faster. In the previous lessons of this course, we discussed creating solids by extruding a sketch and extruding a sketch cut to create a 3D solid based on a 2D sketch and to cut a fragment of a 3D solid based on the 2D sketch. Another way to create 3D solids from a 2D sketch is to create a solid by rotating the sketch. Let's create a new project and create a sketch based on which we will create a solid. Select Create Sketch, and this time select the XZ plane as the sketch plane. Select the line drawing and create a similar shape. And to create such a shape, we select the line command only once and draw subsequent line segments one by one. Okay, let's finish line drawing command, and in a moment we will connect these points together, but the line drawing command is still active, so draw the line that coincides with the x-axis. Okay, press escape to cancel the line drawing command, and now grab this point and move this point near to this point. Okay, and select these 2 points with the Ctrl key and select coincident constraint. Okay, the shape doesn't have to be exactly the same, it is important that is similar. Okay, and then let's add dimensions. But first let's learn how to determine the diameter dimension. Select Sketch Dimension, and to add a diameter dimension, select the line defining the axis of symmetry, then select the outer line of the dimensioned diameter. It can also be a point. We need a dimension that will determine the value of the radius, half the diameter. Okay, select this line, and here the radius dimension will appear, and right click, and from context menu select diameter dimension. This will allow you to enter the diameter dimension instead of the radius dimension. Then define the location of the dimension and enter the diameter value, enter 25 and accept. Okay, let's add other dimensions to the drawing. Select this line and enter 100 millimeters. Next, select this line and enter 40 millimeters. Okay, and sometimes it may happen that when adding dimensions, the sketch will change shape a little, and in such situation we can stop dimensioning and simply drag the selected geometries so that the overall outline of the drawing more or less matches. Okay, I will select the sketch dimension again, and let's add other dimensions. Select this line and enter 60 millimeters. Okay, now select this line and this point, right click and select diameter dimension and enter here 50 millimeters. Now select this line, right click, diameter dimension and enter 60 millimeters. Now select this line, right click, diameter dimension and enter 40 millimeters, and select this line, right click, diameter dimension and enter 70 millimeters. Okay, and let's select this line and enter 170 as an angle. Okay, and the sketch is dimensioned, but the location of this sketch is not yet fully defined. We have several blue lines here, but adding another dimension causes information to be displayed that sketch will be over constrained, and we cannot add a dimension. Let's cancel this and press escape to cancel dimensioning command, and let's use constraint. First, let's create another construction line that coincides with the y-axis. Select line command and draw line like this. Okay, press escape. Then select these two lines and select construction as line type. Okay, deselect selected lines and select coincident constraint. Select this point and this line, and this way the sketch is fully dimensioned and fully constrained. Click Finish Sketch to exit the sketch, and based on this sketch we can create a solid that will be created by rotating this sketch by a specific angle around the selected axis. Select the Revolve command, and the sketch was automatically selected as profile to create a solid. If this did not happen, or if in other cases you have more profiles available, activate the profile selection box and select the appropriate profiles. Next, activate axis selection and select the construction line coinciding with the x-axis as the axis in relation to which the sketch will be rotated. We can select the axis of coordinate system or sketch lines as an axis, and after specifying the parameters, a preview of the solid will appear, and in this case the extent type is set to partial, but the angle is set to 360 degrees, which means it will be a full angle rotation and the solid will also be full, and we will leave this value, but as part for the tests, let's enter 200 degrees, then the solid will be made like this. Let's go back to 360 degrees and click OK to confirm. And in this way we created a solid that was created by rotating the 2D sketch through a full angle of 360 degrees around the selected axis of rotation. This is another way to create 3D solids from a 2D sketch. Let's save this project, enter P4 as the name and click Save. When it comes to creating solids by rotating a sketch, we can also add a material cut by rotating the sketch. We will do it on the project created in the previous lesson. Create a new sketch and select XZ plane as the sketch plane and create a circle. Okay, and select sketch dimension, select circle and enter here 10 millimeters, and select this point and here enter 10 millimeters, and select constrain horizontal vertical and select this point and click Finish Sketch to exit the sketch. Next, select the Revolve command, and by default the sketch has been selected as profile, and as the axis you can select the x-axis, or you can click one of the cylindrical face, then the axis of this face will be selected for rotation. Cut is selected as operation type, and the groove will be created based on cutting this sketch by rotating the sketch around the selected axis. If you would like to add a material, you can change the operation type to join, but here let's set the operation type as cut, and add a cut by rotating a sketch. And just as in the case of an extrude, we can create a 3D solid based on a 2D sketch, and based on the 2D sketch we can extrude a cut. So here we can create 3D solid by rotating the 2D sketch around the indicated axis, and we can create a cut by rotating the 2D sketch around the indicated axis. Okay, these are the basic operations for creating 3D solids in 3D CAD systems. In addition to the basic operations of creating 3D solids, a useful thing is the ability to create text on the faces of the solid. Create a new project and create a sketch on the XY plane. Create a rectangle and create a circle, and let's add dimensions. Here 60 millimeters, here 30 millimeters, 4 as diameter, and select this point, and here enter 5 millimeters, and select this point, and here enter 25 millimeters. Okay, finish sketch and select extrude and add extrusion to 3 millimeters. Okay, and select fillet and select 4 corners of this plate. And here as the radius enter 5 millimeters and click OK to confirm. Let's assume that this is the base of a keychain, and now we will create text on this solid. Select the top face of the solid and select Create Sketch. Then from the Create menu, select Text. And now, just like drawing a rectangle, you need to create a box in which the text will be placed. Draw a rectangular frame by selecting 2 vertices lying on one diagonal. Okay. Then in the text field enter the text, for example F360. The font parameter allows you to select the font that will be used to create the text. By selecting this icon we can make the text bold. In the height field we can define the height of the text, for example 12 or 15 millimeters. Okay, and here we can determine the appropriate alignment. Okay, and click OK to confirm the parameters and click Finish Sketch to exit the sketch. Then select the text and select the extrude, and then by dragging the arrow you can determine whether the text should be convex or concave. Enter here, for example, -1 millimeter and click OK to confirm. And this is how we created the text on the solid. This is useful when creating gadgets, gifts, utility parts, and various types of housings.